Today, we are diving into an essay by Skylar Fiction that does something pretty wild. It connects three worlds you'd probably never, ever think to put in the same sentence. We're going to explore a kind of hidden language that just might unite them all, revealing a shared grammar for reality itself.
So, here it is, the central puzzle. What on earth could possibly link the ancient words of Jesus, the totally mind-bending physics of a quantum computer, and a dry government policy paper? I know, it sounds like the setup to a really weird joke. But the answer? Well, the answer actually gets at something incredibly profound about how we see the world.
So here's how the essay breaks it down. First, you've got theology, where you find speech that literally defines the world, not just describes it. Then you have physics, where reality isn't this solid fixed thing, but more of a cloud of probabilities. And finally, there's policy, where the big challenge is how to manage a new technology that's unbelievably fragile. These are our three building blocks.
Okay, now here's the core argument of the essay we're looking at. It's not just that these fields share a few cool metaphors. No, the claim is much bigger. It's that they all operate on a shared, deep, structural grammar for how reality itself is built, how it's held together, and how we make sense of it.
All right, let's jump into the first parallel. This is the idea that reality isn't just something we sit back and passively watch. It's something that is actively created. You could say it's spoken or measured right into existence. In theology, you see this in what are known as speech acts, where seeing something is the same as doing it. So when Jesus says, "Before Abraham was, I am," the essay argues that's not just a statement of fact. The words themselves are an act of creation, forging a whole new reality that people now have to deal with.
And check this out. Here's the parallel in physics. Before you measure it, a quantum system exists in this weird haze of multiple possibilities all at once. But the moment you observe it, the moment you take a measurement, you force that entire cloud of potential to collapse into one single, definite outcome. Your observation isn't passive. It fundamentally changes what you're looking at.
And that brings us straight to policy. For the scientists and governments trying to build quantum computers, this collapse is public enemy number one. Any unwanted interaction, even from some stray heat or a magnetic field, counts as an observation. Physicists call this decoherence, and it completely wrecks the system, destroying all that valuable quantum potential. So the whole point of quantum policy is to manage that fragility and stop that collapse from happening too soon.
So this idea of potential, it actually gets even deeper. You see, all three of these domains are obsessed with a kind of hidden reality, this world of possibility that's lurking just beneath the surface of everything we can see.
You see this in theology with the parables about the kingdom of God. It's described as something that's already here but isn't obvious yet, like a tiny mustard seed that holds the potential to become a massive tree, or yeast that's hidden in dough. It's a latent reality, not fully visible, but it's packed with transformative power.
And what's wild is how perfectly this maps onto the quantum idea of superposition. A regular computer bit is either a 0 or a 1. Simple. But a quantum bit, a qubit, isn't just a 0 or a 1. Until you measure it, it's actually in a state of being both 0 and 1 at the same time. The true nature of the system is this hidden reality that contains all of its possibilities at once.
And you guessed it, policy takes this concept and tries to turn it into technology. The entire dream of quantum advantage, of computers that could solve problems we can't even imagine solving today, is all about harnessing that hidden potential of superposition. But for now, that potential is mostly just latent. It's trapped inside today's very noisy quantum devices, kind of like a seed that's just waiting for the right conditions to finally sprout.
The parallels get even stranger, though, when we start talking about the very idea of identity. We tend to think of things as separate and individual, but what if they're not?
This brings us to one of the most mind-bending ideas in all of science, entanglement. You can link two particles, so they basically share a single identity. If you measure one of them, you instantly know the state of the other one, even if it's on the opposite side of the universe. Their identity isn't individual anymore. It is fundamentally, deeply relational.
And then you see this striking theological parallel. In this saying, presence and identity aren't locked inside one person. They're actually created through the relationship between people. The identity emerges from the connection itself. It's a kind of distributed presence that isn't in any single location.
So what does policy do with this bizarre connection? Well, it treats it as a core resource for the technology of the future. Entanglement is literally the backbone of the quantum internet, a tool for creating brand new kinds of secure communication that are built entirely on this principle of relational identity.
Okay, so we've walked through all these incredible parallels. What's the big takeaway from the essay? What does all of this actually mean when you put it together?
The author's main point is this: the link between these fields is not just a bunch of clever metaphors, it's much deeper than that. It's a shared underlying structure, a common grammar for describing a reality that is emergent, that is probabilistic, and that is profoundly interconnected.
So here's the crucial point that ties it all together. All three of these worlds, theology, physics, and policy, they all seem to be pointing to a very similar conclusion. They suggest that reality is this fragile, emerging network, that our identities aren't isolated things, but are fundamentally built on relationships. And maybe most importantly, that keeping the whole system coherent, keeping it from collapsing into chaos, requires our constant, active care and stewardship. It means we're not just passive observers of reality, we are active participants in it.
And that leaves us with one last, pretty provocative question. If a hidden grammar really can connect worlds as wildly different as ancient theology, quantum mechanics, and modern government policy, then what other profound connections, what other shared structures are we just completely failing to see in the world all around us?
Welcome to the Deep Dive. Today, we're undertaking something pretty unusual, actually.
Definitely unusual.
We're diving into source material connecting, well, three very different intellectual worlds. Theology, specifically Jesus' core sayings, then fundamental physics, so quantum mechanics, and finally, modern tech governance, specifically QIST policy.
Yeah, quantum information science and technology. It sounds like a stretch, I know.
It really does. You're probably thinking, what on earth links first-century religious ideas, deep physics, and, policy briefs about quantum computing? But our mission here is to sort of extract this unifying framework. The sources suggest these seemingly separate fields actually share a common grammar.
That's the key, a common grammar.
They all seem to treat reality not as this fixed, a solid thing, but as something emergent, something built, maybe moment by moment through, declaration, observation, and how we manage it.
Exactly. It's this repeating intellectual structure that's so striking. It's not about saying physics proves religion or anything like that.
No, not at all.
It's that all three are wrestling with similar core concepts. Uncertainty, this idea of collapse, coherence, keeping things together, and this deep interconnectedness.
A common grammar of fragility and coherence, as one source puts it.
Right, acknowledging how easily things can fall apart, whether that's a physical state, a social fabric, or an information system.
Okay, let's unpack that structural language then. Where should we start? Maybe with that really radical idea about the act itself. Speech or measurement creating reality.
Yeah, that's a powerful starting point, the constitutive act.
The sources argue this act is ontologically decisive, which basically means it doesn't just describe reality,
Right.
it makes it.
Right. Let's start with the theological side, the speech act. In the Gospels, when Jesus speaks, the words aren't just, conveying information, they're performative.
Performative, like doing something.
Exactly. Saying is doing. When he says something like, I am the way and the truth and the life, that statement isn't just a claim. It's framed as establishing a reality, forcing a change.
Okay, I see. The utterance itself defines the situation.
And you find this incredibly similar structure in quantum physics with the collapse of the wave function.
Right, the superposition idea.
Before you measure it, a quantum system is in this cloud of possibilities, right? A superposition of states. But the sources emphasize that the act of measurement, the observation, is what forces it out of that potential into one single definite outcome.
So the observer isn't passive. They're actually involved in picking the outcome.
They participate in selecting it. Yeah, it's not just recording what's already there.
Wow, okay, but wait. If the observation itself creates the outcome, does that mess with the whole idea of objective reality? How do the sources handle that?
That's a great question. It sort of shifts what we mean by objective. The sources seem to suggest objectivity in these contexts isn't about some inherent stability before we look. It's more about the stability you achieve through a very specific, careful interaction. Reality isn't fixed before you interact, but it becomes definite when you interact.
So the focus shifts to the responsibility of the observer, or the person managing the system.
Precisely, because their action has real consequences. It's constitutive.
And that responsibility connects directly to QIST policy, doesn't it? The big challenge there is decoherence.
Exactly. Decoherence, that's the enemy. Any environmental noise, any accidental observation, it just degrades those super fragile quantum states.
So measurement or even just interaction becomes this critical act of governance in quantum tech.
Absolutely. The whole policy and engineering effort is about shielding that quantum system, preserving its coherence, its potential, until you make a very deliberate, intentional measurement.
So the takeaway is massive. If reality isn't fully set until it's articulated or measured, then how we govern those acts of articulation or measurement is, well, it's everything.
It really is. And this idea of governance, it relies on understanding what's hidden, what's potential. Which brings us to the second structural link, this concept of hidden multiplicity.
Hidden multiplicity, meaning there's more going on than meets the eye.
Sort of, yeah. Vast potential hidden beneath the surface of ordinary reality.
Okay.
Theologically, you see this in the metaphor of the kingdom within. Jesus talks about the kingdom being here, but unseen. It's like a tiny mustard seed.
Right, that grows into a huge tree.
Or like yeast hidden in dough, capable of transforming the whole loaf. It's this hidden potential reality that's waiting to be fully revealed.
And that maps directly onto quantum superposition, doesn't it?
It really does. Before collapse, a qubit holds multiple values, 0 and 1 at the same time. Its power, its essence is hidden in that wave of potential outcomes, like you said, until we measure it.
And technologically, QIBN is all about harnessing that hidden multiplicity.
Right.
That's the whole promise of quantum advantage, right? Doing things classical computers can't.
That's the goal. But the sources are clear, especially the policy ones right now, that potential is largely latent. We're in the era of noisy intermediate scale quantum devices, NISQ.
NISQ, meaning they work, but they're messy.
Very messy. Powerful potential, but lots of errors. Very sensitive to noise. The hidden kingdom is there, but the signal-to-noise ratio is still pretty low. It's, it's noisy.
Okay, so we have this hidden potential. How is it accessed? This is where paradox comes in, isn't it?
Yes, exactly. What's really fascinating is how this potential often gets revealed or harnessed through things that seem paradoxical, things that defy simple, linear thinking.
Like what?
Well, think about Jesus's ethics, the reversals. The last will be first. Love your enemies. Turn the other cheek.
Things that seem like weakness, almost.
Right. They resist that straightforward transactional logic, you hit me, I hit you back. Instead, they suggest that what looks like loss or weakness, like turning the other cheek, is actually the pathway to, well, coherence, to system stability. Apparent loss leads to actual gain.
That nonlinear thinking. That feels very quantum.
It absolutely does, because classical probability is linear, right? Things just add up, path A plus path B. But in quantum mechanics, you get interference. Amplitudes combine. Two possible paths can actually cancel each other out, reducing the probability, or they can amplify each other. It's wave-like, and it totally breaks our everyday intuition.
And QST uses that weirdness.
It relies on it. Interference isn't just some weird side effect, it's the engine for quantum algorithms. They use this paradoxical wave behavior potentials canceling or amplifying to guide the system towards the right answer way faster than a classical computer could.
So the paradox isn't a bug, it's a feature. It's the signal.
It's the resource.
Okay, so if reality is constituted by collapse and potential is revealed through paradox, but everything is super fragile, how do these systems maintain any kind of stability? How do they sustain coherence?
Good question. How do you stop everything from just dissolving into noise, whether that's social chaos or quantum decoherence?
Right.
The theological answer, or one of them, presented in the sources, is forgiveness.
Forgiveness as a coherence mechanism.
Yeah. Think about it structurally. In a fragile community, forgiveness stops destructive feedback loops. It cancels debt, restores relationships, prevents endless cycles of retaliation. It's a way to correct errors without destroying the system, like in Blessed Are the Merciful.
Okay, so it's a kind of social error correction.
Exactly. And the direct parallel in QIST is quantum error correction, QEC.
QEC. We hear that acronym a lot. Can you break that down simply? It sounds super technical.
I'll try. So decoherence, the noise, messes up the quantum states, right? It destroys the computation. QEC is basically a clever set of tricks that lets the quantum computer find and fix errors without directly looking at the quantum data itself. Because if you look directly, you'd collapse it.
Oh, okay. So it measures the error, not the data.
Essentially, yes. It preserves the logical information while correcting the disturbances. And forgiveness, in the analogy, works similarly. It addresses the disturbance, the error in the relationship, to restore coherence without obliterating the individuals involved or escalating the conflict.
It preserves the structure.
Right. System integrity isn't about being error-free. It's about having robust mechanisms for correction.
That's fascinating. And this idea of restoring connection, It seems to go right to the heart of identity in these sources.
It does. Jesus' sayings often ground identity not in separation, but in unity. I and the Father are one, or where 2 or 3 are gathered in my name, there am I. Identity isn't just individual, it's relational, even distributed.
And the quantum parallel there is,
Entanglement.
of course, spooky action at a distance.
Right. 2 or more particles linked in such a way that their fates are intertwined no matter how far apart they are. Measuring one instantly tells you about the other. The sources stress this shows that at the quantum level, identity isn't about isolated things, it's fundamentally relational. It defies classical ideas of separateness.
And entanglement isn't just a weird phenomenon, it's becoming a core technological resource.
Absolutely. It's the foundation for quantum communication, for things like quantum key distribution QKD, which promises unhackable communication, and for the future quantum internet.
So managing relationships, in a sense, is the technology.
In a structural sense, yes. Maintaining that fragile, non-local connection is the key.
Okay, there's another surprising convergence you mentioned, resources. How both domains seem wary of excess.
Yes, this was really interesting. Both seem to view having too much, whether it's wealth or, say, too many qubits, not as a source of strength, but potential fragility.
How so?
Well, theologically, Jesus repeatedly warns about wealth. Not just that it's bad, but that it acts like a contaminant. It distorts your perception, creates noise in your judgment. You cannot serve both God and money. Unchecked accumulation seems to undermine the very coherence it's supposed to provide.
And that connects to QST, how we usually think more qubits is better.
Not necessarily, especially not now with these NISQ devices. Adding more qubits often just adds more ways for things to go wrong. More noise, more crosstalk between them, more heat.
Ah, so more complexity leads to more errors.
Often, yes. Unregulated accumulation, just adding more and more components without perfect control, can actually lead to the whole system collapsing faster. More isn't always better when the system is inherently fragile. You need coherence with minimal necessary resources.
So the structural lesson is that just piling up resources, money or qubits, can introduce instability that overwhelms the system.
That seems to be the parallel drawing. Yes, it undermines the coherence you need.
And this leads to a policy concern, right? The quantum divide.
Exactly. If access to this powerful quantum capability, especially secure communication via QKD, gets hoarded by a few wealthy nations or corporations,
It creates a massive imbalance.
a huge asymmetry. It mirrors that theological warning about the rich potentially monopolizing access, creating instability. So the challenge isn't just building the tech, it's ensuring fair access. It's a distributive justice issue, too.
So, looking ahead, where does this all point? Both fields seem to anticipate some kind of major shift, a horizon.
Yeah, sort of phase transition. In the theological sources, you have Jesus' eschatological language, the kingdom of God has come near. It's presented as this hidden reality that's poised for a sudden, full, irreversible reveal, a complete shift in the state of things.
Like water freezing into ice, a phase transition.
Kind of, yeah. A dramatic change from potential to actual, system-wide. And quantum science is looking towards something analogous with the quantum internet.
The point where entanglement can be reliably scaled over large distances.
Right. That's seen as a threshold. Crossing it could unlock completely new capabilities in computing, sensing, communication that are transformative. And the policy documents really stress the need to anticipate this because the impact, potentially destabilizing impacts, could be enormous if we're not ready, if the governance isn't there.
So wrapping this all up, what's the big takeaway from seeing these three disparate fields through this shared structural lens?
I think the unifying lesson or heuristic is that reality, whether we're talking social systems, physical systems, or information systems, seems to function as a network of incredibly fragile systems.
Fragile systems.
Yeah, and they require constant active stewardship. Ethical stewardship, technical stewardship, political stewardship. Coherence isn't the default. It's an achievement.
Yeah.
It has to be actively built and maintained through discipline, patience, foresight.
So let's quickly recap the links we found. Collapse isn't just destruction, it's constitutive. It makes reality definite.
Right, and paradox isn't error. It's a signal of a deeper, nonlinear structure.
Coherence is always fragile, always at risk from noise or decoherence.
And identity isn't isolated. It's fundamentally relational, built on connection, like entanglement.
Okay, maybe one final thought for our listeners to chew on, building on that idea of stability through non-escalation.
Ah, yes.
Both Jesus' ethic of turning the other cheek and the principles behind things like quantum key distribution seem to suggest something profound about stability.
What's that?
That stability in these fragile systems isn't achieved by piling on more force or more energy. It's not about overwhelming power. It's achieved through subtle control, through mastering phase, like in quantum interference, or through structural modulation, redirecting the flow of interaction, like turning the cheek redirects violence away from simple escalation.
So true resilience comes from redirection and subtle control, not brute force.
Exactly. Whether you're managing social conflict or quantum information, that structural insight itself feels like a pretty powerful guide for navigating, well, just about any complex, fragile system.
A deep instruction indeed.
That's our deep dive for today. Thank you for joining us.